Welcome to all in this video. My name is Smith Gaur from Impulse Technology, Delhi, Gurgaon. Today I will demonstrate thermoelectric properties in device structure using an armchair graphene nanoribbon model. You can see here, this is my device studio interface. I'm already named with project 8AGNR. So first we have to make the graphene nanostructure. So go to the build option, then click nanoribbon, then put the values for n equal to 0 and m equal to 4. Click preview option, then click build. This is the nanoribbon molecule is ready. Now we have to make this molecule into the crystal structure. So go to the build option, then redefine crystal, then put the value for C8. Then click again preview, then build option. Now this is the graphene nanostructure. Crystal is ready. Now we have to make this structure into the device form. So go to the build option, then click convert to device, then click left electrode, then right electrode, then preview, then build. So our device is ready for the calculation. Go to the build option, go to the simulator option, then NanoDCAL and SCF calculation. So you can see the SCF calculation for this device. So here you can set your parameters like electron temperature, energy cutoff, exchange correlation. You can also set your exchange correlation value, LDA, GGA, PB, etc. You can also set your K point sampling. I will choose the both for N1, N2, N3, 1. For contour integral, you can also change the values. For electrode, you can also create your own values. For iteration control, basic set, spin type. In spin type, you can set your collinear general type spins. In arrangement, you can also check the arrangement element or atom form. Now click generate files. Now this is the SCF inputs are ready for the electrodes and devices. You can see here. If you want to see your SCF input file, so right click on SCF input, then click open with. You can see here all parameters are shown. You can also change the values from here and save it. So to calculate the to run the calculation, we have to first run the left electrode. You can see here gateway location run parallel. You can change your values. You can select your core, multiple core option here, then click run. Then right click on left electrode SCF input, click run. Then go to the device, click run. As you all can see, in job manager all the calculations are running, and which calculation are not running is it in queue form. After the one calculation is completed, the queue calculation is ready for the next calculation. Since all the calculations are running, in meantime we try to find the another parameters. So go to the simulator option, then NanoDCAL, then analysis, and we have to find the transmissions and seeback coefficient. So select them. You can change the transmission spectrum. You can also change the K point sampling here, and number of K points, energies, energy range. Energy range will be same, -2 to 2. Then go to the seeback. You can also change the values of energy ranges, E min to E max, and you can choose the interval between the energy minimum to energy max. Then you can also change the temperature T minimum to T maximum and between the 50 Kelvin interval. So click generate file. Now go to the transmission input. you can right click transmission input, open with. See, this is the input file for the transmission. You can change the values also here, and for feedback coefficient, open with. You can see this is the SCF input for feedback input. So transmission input, go to the right option, click run. Now next, go to the feedback, click right and click run, then run. Now all the calculations are done. You can see here my all calculations are completed for left electrode, right electrode and device electrode as well. And also my analysis parts also are completed like transmission input, feedback input, I completed. So to get the output of the transmission input, go to the transmission.xml file, click right option, click show view, and you can see here this is my transmission output, which is a transmission coefficient versus energy graph. And for seabed coefficient, you can see, go to the right option, click on show view, and this is my seabed coefficient. You can also check the in different way, which is a chemical potential energy. This graph is between the sigma and chemical potential energy graph. So thank you for watching this video.